Hello, it's Mrs. Palmer. Today's lesson is on solving a system of equations using substitution. There are a few things that we have learned leading up to this lesson, so we are going to have a review of those really quickly, and then I will spend the rest of the time in this video teaching you how to solve a system of equations using substitution. So before we get started, please make sure that you have a piece of paper out and that you have something to write with, and that you also have a calculator, because as I am going through this video lesson, I want you to be following along and doing all of the examples and the practice problems with me. Okay, so remember on our board in class, I have written for you all of the things that you need to know in order to be ready for your system of equations test. So, can I identify the number of solutions for a system of equations? Remember, a system of equations is just two linear equations, and in order to identify the solution, you're looking for the place where the two lines intersect each other at. That point of where they cross each other is called the solution for the system. If the two lines are parallel, they will never cross each other, and so the solution for that system would be no solution. If the two lines are the same line, they would be crossing each other at every single point, and so the solution for that system would be infinitely many. Remember that the way that we are able to tell how many solutions there are going to be without actually graphing the lines is we want to put both of the equations in slope-intercept form and look at their slopes. So if I give you a system that is y equals 3x and y equals 6x minus 9, when we look at these two equations, we can see that these lines have different slopes. And if they have different slopes, that means they are going to cross each other at one point. So there would be one solution. If we look at a system where we have a y equals negative 2x plus 3 and a y equals negative 2x minus 7, we can see that these two lines have the same slope. And if they have the same slope, then they are parallel lines and they will never cross each other. So we would say this system has no solution. If we have two lines, y equals negative 4x minus 2 and y equals negative 4x minus 2, so if this is our system, we can see that these two lines are exactly the same line. They have the same slopes, and they have the same y-intercepts. So we know that if we were to graph both of these lines on the same coordinate plane, they would be crossing each other at every single point. So the number of solutions would be infinitely many solutions. And we actually are going to use this information in today's lesson. So that's why I wanted to review that with you. The next one, number 2, can I verify a solution of a system of equations? So that means that if you have a system x plus y equals 3 and y equals negative x plus 3, and then you have a point like 0, 2, can you verify a solution? So can you tell if this point is going to be a solution to this system? The way that we do that is by plugging the x in for the x and the y in for the y in both equations. If it makes both equations true, it is a solution. So 0 plus 2 equals 3. That is not true. So because this point does not make this equation true, we know this point is not even on this line, So it would not be a solution for this system. In order to be a solution for the system, it has to make both equations true. Okay, the last one. Can I solve a system of equations by graphing? So remember, in order to do this, you put both of your equations in slope-intercept form, you graph them both on the same coordinate plane, you see where they cross. The point where they cross each other is the solution of your system, and that is always listed as an ordered pair. Okay, so that was a quick review of number 1, 2, and 3, and now we are ready to move on to number 4. Can I solve a system of equations by substitution? Now, substitution is just another method that we can use to solve a system. You guys already know how to solve a system using graphing. Today I'm going to teach you how to solve a system without having to graph, but by using substitution. Okay, so let's say that you have the system y equals negative 3x and y equals 6x minus 9. One way of solving this system would be to graph both of these lines on the same coordinate plane and to see where they cross. But today we're going to learn substitution. So in order to do that, our first step is to take these two equations and we're going to write them side by side. Okay, now we can see that y is equal to negative 3x. Okay, so having a y or having negative 3x, that is exactly the same thing because these two are equal to each other. Okay, so that means that we can replace the y with a negative 3x. And that would still leave us with something that is equivalent. Okay, on the second equation, y is equal to 6x minus 9. So that means having a y or having a 6x minus 9 is the same thing. These two are equal to each other. And that's a really important thing to realize when we're solving a system by substitution. So when you solve a system by substitution, you have two equations that both have two variables. They both have an x and a y. What we're going to do is we're going to use substitution to set up an equation where there is just one variable. And then we can solve for that variable. Okay, so the way that this works is we want to identify one of the equations that has been solved for one of the variables. So we can see right here, this y is equal to 3x. So now I'm going to make a substitution in the other equation. I know that y is equal to 3x. So in the other equation, I'm going to substitute this y with 3x. So I'm just going to replace the y with 3x because I know 3x is equal to y. Okay, so we write this other equation just like it is, except for instead of the y, we make a substitution. Now what that does for us is it gives us a new equation that just has one variable. And we can solve this equation for the x very easily. We want to get the two terms that have the same variable to be on the same side. So negative 3 times x equals negative 9. And then we would divide by negative 3. So we get x equals positive 3. Okay, so we know our x value for our solution is 3. To figure out what our y value is, we go back to our first equation, and we know that y is equal to 3 times whatever the x is, but we now know that the x is 3. So y equals 9. Now this gives us an ordered pair, 3, 9, and that is the solution to our system. So if we were to graph these two lines on the same coordinate plane and see where they cross, they would cross at 3, 9. But we found that using substitution instead of graphing. So let's try another one. Okay, so for this next one, we have this system, y equals negative 2x minus 9, and we also have the second equation of y equals 2x minus 1. So our very first step is to take and write these two equations side by side. Our second step is to figure out if one of the equations have been solved for one of the variables, which in this case, both equations have been solved for the y. Okay? So what we're going to do is we know that y equals negative 2x minus 9 in the first equation. So we're going to make a substitution in the second equation for the y. We're going to replace the y with negative 2x minus 9 so that we have a new equation that has just one variable in it that we can solve. Okay? So notice how I wrote this equation just like it is, except for instead of the y, I plugged in negative 2x minus 9 because I know that y is equal to negative 2x minus 9. Now from here, we would add 2x to both sides. So negative 9 equals 4x minus 1. Then we would add 1 to both sides. So negative 8 equals 4x. Then we would divide by 4. So x equals negative 2. Now, once we know what the x is, we can go back to our first equation to figure out what our y is. Because we know that y is equal to negative 2 times whatever the x is minus 9. And we now know that the x equals negative 2, so we can make a substitution in our first equation and solve for the y. Negative 2 times negative 2 is 4. 4 minus 9 is negative 5. Y equals negative 5. The point where these two lines cross each other at is negative 2, negative 5. Okay. Let's go ahead and look at another one. Okay, so let's say we have the two equations, or let's say that our system is y equals 6x minus 6 and negative 3x minus 6y equals 30. Okay, so this is our system. Our very first step when we solve a system of equations using substitution is we put our two equations side by side. Our second step is we solve one of the equations for one of the variables. And in this case, y has already been solved. It's already alone. We know that y is equal to 6x minus 6. So what we're going to do is we're going to take our second equation and we're going to replace the y in our second equation with 6x minus 6. We're going to make a substitution there because we know that y is equal to that. Okay. Now we have an equation that just has one variable that we can solve. Okay. When we combine like terms, we get negative 39x plus 36 equals 30. And then we would subtract 36 from both sides. So we get negative 39x equals negative 6. And then our last step would be to divide by negative 39. And 3 goes into 6 twice. 3 goes into 39 13 times. And a negative divided by a negative is a positive. Okay, so our x coordinate is 2/13. To figure out our y coordinate, we go back to our first equation, we write it just like it is, but instead of the x, we can plug in 2/13, and now we can simplify. So 6 times 2 is 12, that's going to give us 12/13 minus 6, which is going to be -5 and 1/13. So the ordered pair of where these two lines cross each other is 2/13 and -5 and 1/13, which I think that if we were to solve this system by graphing, this would have been a really tricky point to identify. Okay, so let's go ahead and look at another example. Let's say you have 3x plus y equals 9 and 2x plus 8y equals -16. And this is actually number 29 on the substitution assignment. Okay, so the first step is to put our two equations side by side. The next step is to isolate one of the variables in one of the equations. So we want to solve one of the equations for one of the variables. So let's make a really smart choice here. Let's do one that is easy. Can you guys see that this y would be really easy to solve for? We just have to subtract 3x from both sides. So y equals -3x plus 9. So once this y is all by itself, now we can make a substitution for the y in the other equation. So we take the other equation, we write it just like it is, but instead of the y, we're going to make a substitution. We know that y is equal to -3x plus 9. Okay, so now we have a new equation that just has one variable to solve for. So 8 times -3x is -24x. 8 times 9 is 72. And then from there, we would get -22x plus 72 equals -16. So we would subtract 72 from both sides. So -22 times by x equals -88. Divide by -22, and we get x equals 4. Now once we know what the x is, we go back to our original equation to figure out what the y is. The y is going to be equal to -3 times whatever the x is plus 9. We now know that the x is 4. So -12 plus 9 is -3. So if the x is 4, the y is -3. So that means the place where these two lines cross each other at is 4, -3. So if you were to graph both of these lines on the same coordinate plane, this is where they would cross. And we found that by using substitution. Okay, so let's look at another one. This one is actually not on your assignment, but there is one more thing that we need to talk about when it comes to substitution. Remember that your first step is to put the two equations side by side. The second step is to solve one of the equations for one of the variables. And your third step is to make a substitution. In the other equation, for that variable. And remember, our whole goal with substitution is when we make a new equation, when we make our substitution, we want to make a new equation that has just one variable to solve. So that's our whole goal, is to make a substitution so that we have an equation that we can actually solve. Okay, so the thing I wanted to talk to you about is, let's say you have y equals 2x minus 6 and y equals 2x plus 4. Okay, so let's say that you are given a system like this and you were asked to solve the system using substitution. Before you even go through any of these steps right here, you should always look at your two equations. If you realize that the two lines have the same slope and different y-intercepts, you would automatically know that they're parallel lines and there would be no solution. Okay, so you don't even need to go through the process of doing the substitution if you know that the two lines are parallel. Now, if you were to go through the process and you put these two equations side by side and you replace the y in the second equation with 2x minus 6, and you go to solve the equation for the x, your variable is going to drop out and you're going to be left with a statement that is not true. And so that would be another way that you would know there is no solution. So let's say you have a situation where you have y equals negative 2x plus 4. And you also have 2x plus y equals 4. You can see that if we were to solve the second equation for the y, these two are really the exact same line. So we wouldn't have to do the substitution here. Instead, we could say we know that they are the same line, so there would be infinitely many solutions. Okay. Now, if you were to do this substitution, if you were to go through the process of putting the two equations side by side, and you were to replace the y in this equation with negative 2x plus 4, because you know that is equal to y. So if you were to make a substitution, negative 2x plus 4 equals negative 2x plus 4. And then to solve for the x, we'd have to add 2x to both sides. So we would get 4 equals 4. That is a true statement. So when you're solving a system of equations using substitution, and in the beginning you didn't automatically realize that it was infinitely many solutions, and you continued to solve, if your variable drops out and you're left with a statement that's true, again, you would know that there are infinitely many solutions. Okay? So I'm going to do one more with you, and then your practice assignment is a worksheet called 4.2 Practice. Okay, so let's go ahead and do one more together. I just want to make sure that you know how to do this. This is from the 4.2 practice. I am going to go ahead and do number 39. We have 2x plus 3y equals 16. And we have negative 7x minus y equals 20. So remember, your first step is to take and write your two equations side by side. Your next step is to solve one of the equations for one of the variables. Now, you want to make a smart choice here. You want to do something that is the easiest. So I would say solving for the y in this equation is probably going to be the easiest. So let's do that. Let's get the y alone in the second equation. So we add 7x, negative 1 times y equals 7x plus 20. This is negative 1 times y, so we have to divide everything by negative 1. And now we know y equals negative 7x minus 20. Okay, so after we get one of the variables alone in one of the equations, our next step is to make a substitution into the other equation for that variable. So instead of the y, I'm going to make a substitution. So we take and we plug negative 7x minus 20 in for the y in the first equation. Now, you know that you did your substitution correctly if you end up with an equation that just has one variable to solve. Okay, so from there, we're going to distribute the 3. And then we would get negative 19x minus 60 equals 16. So negative 19x equals 76. Then we would divide by negative 9. So x equals negative 4. Okay. Now, once we know that the x equals negative 4, we are going to figure out what the y equals. So we go back to our first equation, and we know that the y is equal to negative 7 times whatever the x is minus 20. We now know that the x is equal to negative 4, so we make a substitution there. Negative 7 times negative 4 is 28. 28 minus 20 is 8. So, negative 4, 8, that is our solution. Remember, a solution is always an ordered pair of where the two lines cross each other at. So if we were to graph both of these lines on the same coordinate plane, we would see that they cross at negative 4, 8. And that is substitution. So your assignment is to do the practice sheet, the 4.2 assignment. We did the odd problems on that assignment. If you're having any questions or you need some more help with this, please come in before school or after school. I am super happy to help you. Have a great day.